I think in the previous class we have seen how to pass structures as parameters to the function. Okay, now here if I take a fraction 3 divided by 8, this is the numerator and the denominator. I say numerator is of type integer, denominator is of type integer. These two fields should be enclosed within braces, and here I write type def followed by struct. And because this is a fraction, the derived data type name what I am going to give is a fraction. Now here what I want is 3 divided by 8 into 4 divided by 7 equal to how much? 3 into 4 12 and 8 into 7 56. So if I multiply these two fractions, this is the answer I am supposed to get. Now if you observe, here we have first fraction number, second, third. 3 fractions are there. So I use 3 variables a, b and c. All are of type what? Fraction, consisting of numerator as well as denominator. Now the moment I say a, here what will happen? Memory will be allocated for the numerator as well as denominator, and these two memory locations are accessed by a single name, by name what? A. Similarly, the moment I say b here, again for b also the memory is allocated for the numerator, memory will be allocated for the denominator, and the name given to these two memory locations is what? B. Similarly, by looking at this, the compiler allocates 2 bytes for n, another 2 bytes for the denominator. This is numerator and this is the denominator, and these two memory locations can be accessed using the common variable by name c. So this is how the memory is allocated for the 3 variables a, b and c. Now what we do is we have to enter the first fraction number, and that first fraction should be copied into which field? A dot n as well as a dot d. So here we have to read into these two memory locations, both are of type integer. So how you access this field? A dot n. How you access this field? A dot d. So here I write ampersand a dot n, ampersand a dot d, and remember both n and d are of type what? Integer. So we use format specifier percentage d, percentage d. But because when in the input we want 3 divided by 8, so here only I write slash here. So to how to read this data from the keyboard, for that we have to use scanf function. Now here we have percentage d slash percentage d. So when you are inputting the values, you should write 3 slash 8. In that case, 3 will be copied into which field? A dot n. And normally before scanf what we write? Printf. Now when these two statements are executed, if the user types 3 slash 8 from the keyboard, that 3 slash 8 will be copied into the numerator and the denominator field. Similarly, I have to read the value for b. So here what is the input? This is the numerator and this is the denominator. So b dot n and b dot d, into these two memory locations I have to copy this. So what we write here? Ampersand b dot n and ampersand b dot d. Both the numerator and the denominator are of type what? Integer. So the format specifier what we use is percentage d, percentage d. And because we have to read the data from the keyboard, I write a scanf here. Now normally before scanf what we write? Printf. So I write printf enter fraction 2. So if I input 4 slash n, that 4 slash n will be copied into b dot n and b dot d. Next, what we have to do? We have to multiply these two fractions, and the result has to be stored in the variable c. For that what I do? Here let us multiply a and b. I use multiplication operator here. The result of a into b must be copied into c. Now we have to multiply these two fractions. So for that I use one function by name multiply, and for that multiply, how many arguments we are passing? 2 arguments a and b. So here this is a and this is b. These two must be passed as the arguments for the function multiply. So after multiplying a, b, what the multiply function returns? It should return 12 by 56, which you are supposed to copy into the variable c. So here the value or the fraction returned by the function multiply, that I am going to copy into which variable? C here. Now let us see what will happen here. So if this function multiplies a and b, 3 into 4, how much? 12. Here we get 12. 8 into 7, how much? 56. We get 56. So this is the variable. The variable c contains what now? 12 divided by 56. So it is the responsibility of the function multiply to multiply the two fractions a and b and return the result, so that that result is copied into which variable? C. How to write this function multiply, that we will see later. Now what is there in variable c? C contains one fraction, that is 12 divided by 56. Let us try to display this. So we can display c dot n and c dot d. Both are of type what? Integer. So it is a format specifier. I should use percentage d. So here I write printf result equal to percentage d slash percentage d. So what is the output? You will get 12 here. So here percentage d followed by what? Slash. So the output will be 12 slash 56. And all these statements, our job is over. All these statements must be enclosed within braces like this, and here we write void main. I hope you understood how to write the function main. And what is our observation? The whole function main is written by assuming multiply function is already there. But remember, multiply is not a built-in function. It is not inbuilt function. We have to write our own function. So we say multiply is user-defined function. Now let us see how to write. Look at this. The printf and scanf, the declaration of printf and scanf is available in stdio.h. So go here and write hash include stdio.h. Now let us write the function multiply. Here how many arguments are there? 2 arguments are there, and here we require how many parameters? 2 parameters. So let me use x and y. The value of a will be copied into where now? X. The value of b will be copied into y. The number of arguments should be same as the number of parameters. Similarly, type of a and b, type of arguments. What is type of argument a and b? Fraction. So the type of parameter x and y also must be of type of fraction only. So here I say x is of type of fraction, y is also of type of fraction. Now what is there in x now? 3 divided by 8. What is there in y? 4 divided by 7. Now these two parameters must be enclosed within parenthesis, something like this. Now what this function multiply has to return? It has to return 12 divided by 56, which is of type of fraction only. So here I say the return type is a fraction. Now I use one variable z, which is of type fraction. Now let us multiply these two. Tell me how you get 3 and how you get 4. This will be x dot n. This is x. X dot n means what? I will get 3. It has to be multiplied with 4. What is 4 here? Y dot n. See here. A is nothing but 3 divided. A will be copied into x, B will be copied into y. So this is y and this is x. X dot n should be multiplied with y dot n. What is y dot n here? 4. And so 3 into 4, how much? 12. That 12 should be copied into which variable? Z dot n. So the numerator is over. Next we have to calculate the denominator. 8 into 7. Where is 8? Using the variable x, how you access 8? X dot denominator should be multiplied with y dot denominator, and the result should be copied into z dot d. Now z dot n contains 12 and z dot d contains how much? 56. So together the variable z contains 12 divided by 56. It means we have multiplied the two fractions x and y, and the result is available in the variable z. What to do? We have to return z. The moment I say return z, what will happen? This 12 divided by 56 will be copied into variable c. So if I print c, what is the output? I will get 12 divided by 56. Now these 4 statements, 1, 2, 3, 4, this is the declaration statement, and these are all what? Executable statements. All those statements must be enclosed within parentheses. Braces like this. So this is your complete program, which shows how to pass structures as parameters to the function, and how we get, if you observe, one more point if you observe, what z contains? Z contains 12 as well as what? 56. So we are returning more than one value to the function. So if you want to return more than one value to the function, you go for what? Structures. Now we know how to pass structures. Now let us see how to pass address to structures, address of structure to the function. Now if you observe here, we are not passing address of A, we are not passing address of B. Now let us pass address of three structures A, B and C. Now I'll change this. So here I write multiply address of A, address of B and address of C. Now how many arguments are there? 3 arguments are there. So naturally here require how many parameters? 3 parameters I use. And remember the function multiply. What is the A? A contains 3 divided by 8, B contains 4 divided by 7 and C, the result C will be the result 12 divided by 56 is available in the variable C. So the function multiply need not return any value. So I change this fraction, return type of fraction, return type fraction to what? Void, indicating the function multiply. Earlier it was returning what? Fraction as the data type. Now multiply function will not return any value. So the return type is void. Here how many arguments are there? 3 arguments are there. Here we require how many parameters? 3 parameters. So I write x, y and z. So A, B, C. This is A, this is B. A and B will be copied into x and y. This is C. Nothing is there in C, but that will be copied into which variable now? Z here. So this is identified by x, this is identified by y and this is identified by z in the function multiply. Now here we are passing address of A, address of B. So here what I do? I remove this return z. If I remove return z, and here I can write, I can remove this also because the return type is what? Void. Z you need not declare here. Z you need not declare. The reason is z is passed as the parameter, so you need not declare z. So I remove return z because the return type is void. Now if you observe, here we are passing address of A, address of B and address of C. Address of A should be copied where now? X. So if you want to store address x in the variable, then x must be declared as a pointer. Maybe in the next section, next chapter, we see how to use pointers and what is a pointer. So what happened here? Address of A is copied into which variable? X. Now the variable x contains address of another variable. So whenever a variable such as x which contains address of another variable, say address of A, then we declare x as a pointer by prefixing star. Now the moment we have prefix star, we say x is a pointer. Now tell me what x contains? Address of A. Similarly, here we send address of B, and address of B should be copied where now? Y. Because the variable y should contain the address, y should be declared as a pointer. Now tell me how you declare y as a pointer? Put star here. The moment you write star in the declaration, it means y is a pointer, it should contain only the address. So x contains address of A, y contains address of B. Next, address of C is copied into Z. So Z also contains address, so Z should be declared as a pointer. Tell me how you declare Z as a pointer? You prefix a star here. The moment you prefix a star, it means Z becomes a pointer. That means Z contains address of C here. Now the question is how you access this value, how you access this value. If x contains address, to get the data in that, we write star x. So this has to be written star y. So I write here address of A, address of B, address of C we are passing. That is the reason we are using x and y, x, y, z as what? Pointers. Now how you access the data stored in the variable x? You use a star operator. So this has to be written as star x dot n, this has to be written as star y dot n, like this. Only thing is star x must be written within parenthesis and star y also must be written within parenthesis. when you have to use star operator here? Whenever x contains an address, so to access the contents, we write star. Similarly, instead of writing z dot n, what should I write? Star z dot n. Now tell me, how you write x dot d? X contains a pointer. X is a pointer. It contains what? Address. Now, if x contains address, this has to be replaced with what? Star x dot d. Just write star here. Here also we write star y dot d. So, now 3 into 4 how much? 12. 12 is stored in the variable z dot n. Now look here. This x dot d can be written as star x dot d, and here y dot d can be written as star y dot d. Now, what is star x dot d means? 8. Star y dot d means 7. 8 into 7 how much? 56. 56 should be copied into what z contains? It is a pointer. So, z contains address. Address of this we want to store into this. So, here we have to prefix what? Star. So, I write star z dot d. Now, 8 into 7 how much? 56. That 56 is copied into this location. Now, if you observe, even though we are not changing x, n and z, the values of the actual parameters. What is the value of the actual parameter here? C. C changes. Here, even though using z, actually using z, we are trying to access the variable c. So, this is passed by address. So, using the formal parameter z, we are trying to change the values of c. So, the values of c have been changed to 12 divided by 56. So, this way of passing parameters is called pass by value. I hope you understood how to pass the members of the structures as parameters, but instead of passing structures, we are passing address of structures as parameters to the function multiply. Now, whenever you use two operators star and dot like this, star x within parenthesis dot, instead of using this syntax, you can simply write x arrow mark n. So, like this, x arrow mark n, y arrow mark n is same as what? Star x dot n, star y dot n. Here also, instead of writing star z dot n, what you can write? Z arrow mark n. So, here we say arrow is, it is an operator. So, z pointing to n is something but x pointing to n multiplied with y pointing to n. Similarly, here this has to be changed to what? X pointing to d, y pointing to d, both are multiplied and the result is available in the variable z pointing to d. This is z pointing to d, which is nothing but how much? 56. So, now we have seen how to pass members of a structure, how to pass structures, and how to pass address of structures to the function. Okay, now in this complex numbers, let us see how to represent complex numbers. You don't have any data type in C language to represent complex numbers. Can you tell me what are all the data types we have? Int we have, float we have, char we have, double we have, but we don't have complex data type. So, let me take an example, say 3 plus 4i. How to represent this complex number using C program, C language. Now, in mathematics, we call this as the complex number, and each complex number has two parts. One is the real part and another is the imaginary part. What is the real part here? 3. What is the imaginary part? 4. So, here let me represent this complex number. So, here I say real part. Here I have taken 3. It can be 3.5. It can be 9.5. So, it is a floating point number. So, I say real part is of type what? Float. Similarly, instead of writing 4 here, I can write 4.5. I can write 3.5 and so on. So, imaginary part also can be of type float. So, here I write I stands for what? Imaginary. Imaginary number is of type float. So, together the real part and imaginary part together I call it as what? Complex number. So, I have to give a common name I have to access both real part and imaginary part using the common name. So for that what I do, I enclose within the braces. Here I write type def structure, and here I write complex. Now complex is derived from these two floating point numbers, which I say this is the real part and which I say this is the imaginary part. So that's how a complex data type can be derived from using fundamental or basic data types such as a float. Okay, now here let me say A is of type complex, and the moment I say A is of type complex, memory will be allocated for the real part, memory will be allocated for what? Imaginary part. So for real part, how many bytes? Real part is of type what? Float. So flow 4 bytes of memory is allocated for the real part, and another 4 bytes will be allocated for the imaginary part. Now the entire real part and the imaginary part can be accessed using the common name A. So I write A here. Next, I write complex B, another complex number. So what will happen? Memory will be allocated for the real part, memory will be allocated for the imaginary part. These two locations have a common name. What is the common name we have here? B. So here I write B. Now let me write another declaration. Say I write complex C. Now tell me, by looking at this statement, what the compiler will do? Compiler will reserve 4 bytes for the real part, another 4 bytes for the imaginary part. These two locations can be identified using the common variable C. So here I write C. So this is one complex number which is identified by A. This is another complex number consisting of real part and imaginary part, and it is identified by the variable B. There is another complex number which consists of real part and imaginary part, and this is identified by the variable C. Now suppose we have one real part contains 4 and imaginary part contains 6. What is the meaning of this? 4 plus 6i. 4 plus 6i can be written in the memory like this. So this is the first complex number. Suppose this is second complex number, 3 plus 7i. The 3 plus 7i can be stored in the memory using real part and imaginary part as shown here. Now our intention is to add these two complex numbers. So what we write here? Plus. We add A, we add B, and let us store the result in the variable C. Now the question is, how you add real part? 4 plus 6i, 4 plus 6i, 3 plus 7i. If I add these two, real part of the first number should be added with real part of the second number. So now tell me, how you access real part of the first number? So here I can write A dot R using A, and how you access this field? A dot R. If I say A dot R, what I get here? 4. So this will be 4. Next what we have? B dot real part, B dot R. So what is B dot R here? 3. So 4 plus 3 is how much? 7. 7 should be copied into this location. Tell me how you identify this location? C dot R. So A dot R plus B dot R equal to how much? C dot R. Similarly, now tell me what is the answer? 4 plus 3, how much? 7. 7 should be copied into which field? C dot R. So here we get 7. Similarly, 6 plus 7. This is the imaginary part of the first number. This is the imaginary part of the second number. And both of them we have to add. 6 plus 7, how much? 13. So how you access this? A dot I. How you access this field? B dot I. So here what should I write? A dot I plus B dot I, and I have to store the result in C dot I. So 6 plus 7, how much? 13. I want to store 13 here. How you store 13? Here you have to write C dot I. So what is C dot I? 13. So this is a complex number, a new complex number. This is the sum of A and B. 4 plus 3 is 7. 6 plus 7 is how much? 13. So this is the result. You have to give the result to the function main. So I write return C. If I write return C, this fraction, this complex number goes to the calling function. In our example, calling function is the function main. Now all these statements must be enclosed within braces here. What we are returning? C. C is of type what? Complex. So here I write complex. this return type complex has to be followed by name of the function. What is the name of the function? Add. So this is the complete function which is used to add two complex numbers and return the result. Now here, now tell me, what is this A and B? A and B are called parameters. The syntax is all parameters must be enclosed within parentheses like this. So now we have written a complete function to add two complex numbers. Now let me write another function to subtract a complex number from other complex number. I want to compute A minus B. To compute A minus B, first of all, you require one complex number A. We require another complex number B. Now when I say complex, what will happen? Memory is allocated for the real part and imaginary part. These two locations can be accessed using the common name A. I require another number, so I write complex B. The moment I say complex B, what the compiler will do? Compiler will allocate memory for the real part. It allocates the memory for the imaginary part. And these two memory locations are identified by the common name B. So this is one fraction number, this is another fraction number, and these two I should compute A minus B. So let me use another complex number, say C. So memory is allocated for the real part, memory is allocated for the imaginary part. These two locations are identified by the common name. What is the common name given for this? C. Now you tell me how I should how should I perform A minus B? This complex number minus this complex number, what is the result? Let me store 4 and 6. This represents 4 plus 6i. And let me write 3 by 3 and 4. This is 3 plus 4i. So 4 plus 6i minus 3 plus 4i. So let me compute minus. And the result must be copied into which variable? C. Now tell me how you subtract a complex number from other complex number. This is the real part and this is the imaginary part. So real part minus real part of one number must, and we have to access the real part of the first number and then real part of the second number. What is the real part of the first number? 4. Real part of the second number? 3. So what I have to do? Take 4, take 3 and perform subtraction. 4 minus 3. What is 4 minus 3? 1. Now tell me how you access this. I can say A dot R minus how you access this? B dot R. So 4 minus 3 is how much? 1. That 1 should be copied into which location? C dot R. So I write equal to C dot R. Now tell me what is the answer we get? 4 minus 3. It is 1. 1 I am going to copy here. Similarly, I have to access 6. I have to access 4. 6 minus 4 I have to compute. So how we access 6? Using the variable A and I can write A dot I. So here I write A dot I minus B dot I. What is B dot I here? 4. 6 minus 4 is how much? 2. That 2 should be copied into where now? C dot I. So here I write 2 here. So 4 plus 6i minus 3 plus 4i is nothing but what? 1 plus 2i. Remember, the result is available in which variable now? The variable C. So here let us return the result C to the calling function. Okay. Now what is the return type? C. What is C? C is of type complex. So return C means the return type is also of type complex. How many statements are there here? 4 statements. All those 4 statements must be enclosed within braces like this. So C is of type complex. So here what I write? Complex. What is the name of the function? Subtract. So here now tell me what is A and B? A and B are called what? Parameters. Parameters must be enclosed within parentheses. So that's how we can write the function add, we can write the function subtract. On similar lines, let us see how to multiply two complex numbers. Now, as usual, again I say A is of type complex, meaning memory will be allocated for the real part, memory will be allocated for the imaginary part, and the entire memory locations are these two memory locations R and I. we call them as fields, can be accessed using the variable A. Now if I say complex B, what will happen? Memory will be allocated for the real part, memory will be allocated for the imaginary part, and these two memory locations or the fields can be accessed using the common variable, what? The common variable B. Next, if I write complex C, again real part and imaginary part memory will be allocated, and these two locations are identified by the variable what? C. Now tell me how to multiply two complex numbers. Now let me explain with mathematical expressions how to multiply A and B. Suppose x plus yi is your A, A plus bi is your B. These two complex numbers are there. I have to multiply. Tell me how you can multiply. X into A. So here I write xa. Then plus x into bi. If I say x into bi, what is the answer we get? xbi. So x is multiplied with A, x is multiplied with bi. Next, what you should do? Yi should be multiplied with A. Yi should be multiplied with A. So what you write here? Plus yai. Next, after multiplying yi with A, we have to multiply yi and bi. So what is the result? Yb. Y into b, yb. I into I is what? I square. So I get plus yb I square. Now, I write this xa as it is, plus xbi as it is, plus yai as it is. Now tell me what is I square? I square is minus 1. So this will be minus yb. Now if you observe, we have xa here and here we have yb here. So this xa and minus yb represent the real part. So I write xa minus yb represent which part? The real part. Then plus, if you take I outside, so what we get here? Xb plus ya, it has to be multiplied with what now? Y. So this is the real part of the result and this is imaginary part of the result. I hope you understood how to multiply two complex numbers mathematically. Now let us see how to implement that multiplication of two complex numbers using the C program. Now let me take C dot R, the real part. How you get the real part? C dot R, this is the real part. If you observe xa, what is x and a? X is the real part of the first number, a is the real part of the second number. That means real part of the first number has to be multiplied with real part of the second number. What is the real part here? Real part of the first number? A dot R. What is the real part of the second number? B dot R. So here x and a means real part of the first number and real part of the second number, which is nothing but a dot r into b dot r. So I write a dot r into b dot r. Then what we have here? Minus. So let me write minus. Next, now here if you observe what we have here, yb. Now tell me what is y and b here? Y is the imaginary part of the second number, imaginary part of the first number. This is the first number, this is the second complex number. Y and b, if you observe yb, y is the imaginary part of the first number, b is imaginary part of the second number. So imaginary part of the first number, imaginary part of the second number we have to multiply. So this is imaginary part of the first number, this is imaginary part of the second number. We have to multiply these two. So tell me how you access this field. A dot I has to be multiplied with this field, that is b dot I. So here I write yb corresponds to what here? Real imaginary part of the first number and imaginary part of the second number. That means a dot I and b dot I. So together we whatever result we get, that we copy into where now? Real part of the variable c, that is here we get. On similar lines, look here, this is the imaginary part of the result, xb. What is x, what is b? real part of the first number, imaginary part of the second number. What is the real part of the first number? A dot I. Imaginary part of the second number, B dot I. I am sorry, what is this x here? Real part of the first number, that is nothing but A dot R. So here I write A dot R should be multiplied with what? Here B. What is this B here? Imaginary part of the second number. What is the imaginary part of the second number here? This field. How you access this field? B dot I. So here I write B dot I. Then what is the operation we have here? Plus. So I write plus. Now tell me how you access YA. What is YA here? Imaginary part of the first number and real part of the second number. So how you access imaginary part of the first number? A dot I. So here I write A dot I into what? A. A is a real part of the second number. If A is a real part of the second number, how you access the real part of the second number? B dot R. So that is the reason we have B dot R. And the result has to be copied into which variable? C dot I. So that's all. Now multiplication of two complex numbers is also over, but tell me what is the result? C. I write return C. And these four statements must be enclosed within braces. When I say return C, C is of type what? Complex. So here I write complex. Now tell me what is the operation which is being done here? We are multiplying two complex numbers, so we write multiply. And A and B are what? Parameters. The parameters must be enclosed within a parenthesis like this. Now we have seen how to add two complex numbers, how to subtract one complex number from the other, and finally we have seen how to multiply two complex numbers. On similar lines, you can divide a complex number by other complex number. Now let us write the function main. How to access complex various functions, add, subtract and multiply. Now here for that let me use the variable a, b, x, y and z. Now actually a and b are what? Given numbers. We add a and b, store the result in x. A minus b we perform, store the result in y. A into b we perform, that is multiply two complex numbers, let us store the result in z. So here x contains sum of two numbers, that is a plus b, y contains a minus b, z contains what? A star b. All variables should be of type what? Complex. So we say this complex is derived from the basic data types, so it is a derived data type. Now let me see how to read the first complex number, that is real part and imaginary part. I can access by writing a dot r and a dot I. Both are of type what? Float. So let me write percentage f, and we have to use a scanf function. Normally before scanf we write printf. What is a printf statement? Enter the real part and imaginary part of the first number. After reading the first complex number, let me read the second complex number. So how you access second complex number? Real part can be accessed using b dot r, imaginary part can be accessed using b dot I. Both are complex numbers, that means they are of type what? Float here. So we use format specifier percentage f, and this also has to be percentage f only. There is a mistake here, it is not percentage d, it has to be percentage f. And what is the function I should use? Scanf. Normally before scanf we write a printf. So here I write printf. So here we read the first complex number and here we read the second complex number. Now tell me what should I do? What should I do with this a and b? We have to add. So call the function add. Add what? Two complex numbers a and b. And store the result in which variable? X. So here I write x equal to add a comma b. Next I have to subtract complex number. So let me use the function subtract. Let me pass two arguments a and b. It means a minus b. So a minus b, let us store the result in the variable y. So I write equal to y. And finally let us multiply two complex numbers a and b. To multiply two complex numbers a and b, what should you do? Call the function multiply, which already I have explained, and pass two arguments as the two arguments a and b, and let us store the result in z. So I hope you understood. Now let us try to display the answer. So here x plus y equal to percentage f plus percentage of I. This is a real part and this is imaginary part. Real part is available in which variable? X dot r. Imaginary part is available in x dot I. So here we get the result in the form a plus ib. Now what about the a minus b? I can write on similar lines. Printf x minus y is equal to percentage f plus percentage f, here y dot r and y dot I. And similarly, how to display z? We write printf x star y is equal to percentage f plus percentage f I. So here I write z dot r and z dot I. Now my job is over. So here we are adding two complex numbers, we are subtracting one complex number from the other, and we are multiplying two complex numbers. Here we read two complex numbers, here we add two complex numbers, here we subtract one complex from the other, here we multiply two complex numbers, and here we display the sum, the subtracted result and the multiplication result. All these statements must be enclosed within braces, and here I write void main. And how to write the function add? Already I have explained in the previous slide. We know how to subtract, we know how to multiply. So these three functions are called in the function main. Now tell me, add is called what? Called function. Subtract is also called function. Multiply is also called function. Who is calling all these functions? Main is calling all these functions. So we say main is called calling function. Now the declaration of printf and the declaration of scanf is already available in the header file stdio.h. One thing you remember, don't assume that printf is written in stdio.h. Scanf, the function scanf is written in stdio.h. No, it's totally wrong. The function printf, it is there, and scanf is also there in the library. But the declaration of printf and scanf is available in stdio.h. So we include stdio.h in the beginning. Either you can write here or you can write here, no problem. Now I think we have completed structures, and next chapter is file handling. Now let me concentrate on file handling. This is a new chapter. I think in the module 3 we have one structures and another file handling. Now let us concentrate on file handling. Before this, let me ask one question to you. Tell me, what are the disadvantages of reading the data from the keyboard? Tell me, what are the disadvantages of reading the data from the keyboard? Now if you observe, here we have the keyboard and here we have the monitor. Normally we can read the data from the keyboard using scanf statement, and we can display the result onto the screen using printf. We can read the names from the keyboard using getS function. We can display the names on the screen using putS function. Similarly, we can get a character from the keyboard using getChar function, and we can display a character on the screen using putChar function. So using scanf, printf, getS, putS, getChar, putChar, we can read various types of data from the keyboard and we can display it onto the screen. Now what's our observation? Reading the data from the keyboard works fine whenever the input data is very less. So if the input data is very less, we can read the data from the keyboard very easily. But this way of reading the data from the keyboard results in following problems. Let us see what is the first problem. The first problem is, during the development of the program, suppose we are designing the program and we are writing the program, when the program is being developed, we may have to input say 10, 20, 30, 40, 50 and so on, and find that the program is not working. Then what we do? We have to correct the program, re-execute the program. Again we have to input 10, 20, 30, 40, 50 and check whether the result is correct or not. Again, if the result is wrong, again what we have to do? Edit the program, correct the program and execute it. Again we may have to input the data 10, 20, 30, 40, 50. So during the development of the program, we may have to input the same set of data repeatedly to check whether the program is correct or not. So during the development phase, we may have to input the same data repeatedly. That means we have to enter the data from the keyboard repeatedly. It is very difficult to input large volume of data using the keyboard repeatedly. Okay, here we may enter 2 or 3 data repeatedly, but if I want to enter 100 numbers every time 100 numbers, then it is very difficult. So it is very difficult to input large volume of data using the keyboard repeatedly. Suppose I am having some 100 numbers here, 10, 20, 30, 45, 50 and so on, then again 10, 25, 30, 45, 50 and so on. 100 numbers are there. After typing 100 numbers from the keyboard, later I realized that there is a problem in the third number. Instead of 35, I have written what here? 30. Then in that case what I have to do? I have to remove all these numbers. Again I have to type it, I have to retype it as 35. Again I have to retype these numbers. So after entering the large volume of data, suppose there is a wrong entry somewhere in the middle, then we may have to retype the entire data. So instead of retyping the entire data, what we do? We enter this data and store the data in the hard disk. Hard disk I represent something like this. So this is hard disk, or it may be CD, or it may be DVD, any secondary device. I am going to represent like this. So let us see how to store this data into the hard disk. For that, we can invoke any of the editor. Let me invoke the notepad. Let me enter these numbers here, 10, 20, 30, 40 and so on, 50. If 100 numbers are there, you enter all 100 numbers. If you want to change, here you can change. And once you know that the data is correct, you can save this particular file. Save it using the file input.dat on the hard disk. Now the contents 10, 20, 30, 40 and so on up to 50 will be transferred to the hard disk and the data is saved permanently on the hard disk. I hope you are following. Now what we do? Let us try to how to access the data which is stored in the disk. That can be done using one function by name fscanf. Scanf is used to read the data from the keyboard. Fscanf is used to read the data from the secondary devices such as floppy disk or hard disk and so on. Now after reading this data 10, 20, 30, 40 and so on up to 50 using which function? Fscanf function. Let us manipulate the data and write it into the disk, and we write into the disk using the output file by name output.dat. Suppose the data read is manipulated, and let me write it as 50, 40, 30, 20 and so on up to 10. So the manipulated result has been written into the secondary device using the file output.dat, and we can start writing this data into the disk by using fprintf function. So fscanf function is used to get the data from the disk. Fprintf function is used to write the data into the disk. So fscanf is used to read the data from the disk and fprintf is used to write the data into the disk. I hope you understood what is the importance of files. Now let me see what is the advantage of using a file. Point number 1. The data typed in from the keyboard can be written into a file, and the file which contains the data can be saved permanently on the hard disk. So this is the data which we have entered from the keyboard, and that data is permanently stored. unless you delete, this will be there in the hard disk permanently. So that is the advantage. You need not type 10, 20, 30, 40, 50 each time, because the data is already stored in the hard disk. You read it, manipulate it and write it back. Point number 2 is, during the development of the program, when the program is re-executed each time, we do the correction. The data can be read from the input file very fast. So if a program there is something wrong in the program, we correct it and we have to read the data from the file, and the data can be read very fast from the file. So that is a point we have given here. During the development of the program, when the program is re-executed, each time we do the correction, the data can be read from the input file very fast. Point number 3 is, a very large amount of data can be read within a fraction of a second. The very large volume of data can be read from the hard disk within a fraction of a second. I hope you understood the advantages of the file. Now the question is, what is a file and what are the activities performed on files? Now if you observe, tell me what are the main activity what we did here. We read the data from the file and we write the data into the file. So the first activity what we do is reading the large amount of data from the disk and writing the large amount of data into the disk. So these are the main two operations that are always performed. Most of the time we perform only reading and writing only. Now if you observe, these are the two activities that will be performed on files. So what is this input file contains? This input file contains the data that we have typed from the keyboard and we have saved here. So an input file contains the items that we have typed in from the keyboard. Now tell me, what is this? This is the output file. What it contains? This is the data that we have written into the file. The output of the program can be written into the output file. This is the input data and this is the output data. Input data is available in the input file. Output data is available in the output file. Now tell me, what is the definition of a file? A file is defined as a collection of data stored in the secondary device. When I say collection of data, we can store integers, you can store floating point numbers, characters, anything you can store. So it is a collection of data stored in the secondary device, such as a hard disk. An input file contains the items that we have typed in from the keyboard. The output of the program can be written into the output file. So the data can be read from the file using which function? fscanf function, and after modification the data can be written into the file. The data can be written into this file using which function? fprintf function. Now we know what is a file and what are the main activities performed on files. The main activities that can be performed using a file are: one is reading the large amount of data from the disk and another writing the large amount of data from the disk. I think we can stop at this point and let us concentrate on how to manipulate a file, how to open a file, how to close a file, how to read a file, and what is the syntax in detail. Okay, thank you very much.